Hello, this is Denton Yoder, instructor for ESE 2304, the Biological Systems Engineering CAD class. In today's R file, I'd like to teach you a little bit about some of the survey tools that you'll be using in next labs. The first thing to look at is the rod. A rod is a extendable ruler. The face of the rod is numbered starting at the bottom, and if you want to increase it, you can extend it. When extending the rod in its first use, which is using the numbers, you would extend it each section one at a time as you need it, starting with the lower sections. The rod is a ruler, and you'll use that with an optical level. Let me share my screen. Okay. This is a picture of an optical level and a person using it. The optical level is mounted on a tripod and leveled manually. You can spin it a full 360 degrees, and the degrees are marked on the side of the level. We typically don't use it for measuring angles at all, but we use it for measuring elevations. So if you have any known elevation, you can put the ruler on the known elevation and look at what number you have on the sight glass. By adding the known elevation plus the measured elevation, you now have what they call height of instrument. Now you can measure any other place on your job site, and you subtract your measurement from the height of instrument, and that will give you the ground elevation at that point. Okay, I'm going to stop the sharing of my desktop and go back to the video. Okay, the other way to use this, well, before I show you the other way, let me show you how to collapse it. On the back side is a button that snaps when you fully extend. Make sure there's no weight on it, and you can easily press the button, then slide it together slowly and get your finger out of the way before it guillotines it off. And you can easily retract it. If you can't easily retract it, something is going wrong. Okay, let me screen share again, and I'll show you the second way levels are used. The second way is called a laser level. Share screen, switch to laser level. Okay, a laser level is also mounted on top of a tripod, and it spins a laser so that your height of instrument is a plane defined by the laser beam. Now, instead of having, well, you can see them here, we have a nice one, and we have some really inexpensive ones as well, construction grade. Actually, I don't see the cheap ones on this page. This one has mostly the expensive ones. Let me stop the screen share. And here is a laser indicator. The laser indicator will beep when you hit the elevation of the laser. Now, our rod has two purposes. I mentioned the front is for measuring distances. The back side we use with the laser indicator. The back side is numbered differently, and you extend it differently. You actually extend it from the top section first, and your elevations are noted, your distances are backwards. It's really kind of weird. It starts out at 5 foot. 5 foot is the height of the pole. So if your laser indicator is perfectly on the top of the pole, so that the indicator line lines up with the top of the pole, and you're reading 5 foot at the line or it hits the next segment, the laser is exactly 5 foot. You will raise the pole slowly while it's in an upright position, listening for the beep. You will get a beep pattern whenever it encounters the laser. There will be one beep for too high, another beep for too low, and pretty much a steady beep in the middle. So you continuously raise it until you hear the beep. Then right at the line, you record the distance as your measurement. Once it reaches the extent of one pole, it will click, and then you're raising the second pole. To collapse it, you have to raise it a little bit so you get the black dot. Hold the dot in, slowly collapse it, get your finger out of the way, and then you can fully collapse it again. So the numbers you use with an optical level. The back side, the red side, you use with the laser indicator. Both are considered a level. If you're using the optical level and you're using the numbers, standard practice is for the person holding the rod, which this is the rod, is to rock the rod forward and backward slowly. The person towards the instrument. The person looking through the instrument will see a sliding value based on your rocking. The lowest number they see will be when it's perfectly perpendicular. So they'll see a higher number, lower number, higher number, lower number. Record the lowest number because that is the most accurate distance. So we've learned how to use an optical laser, and we've learned how an optical level and how to use a laser level. We will do that in the next lab. Thank you very much. Bye-bye. Oh, let me add one more. We are recording from the first point we selected plus the reading we got to make our height of instrument. All the rest of the readings we will subtract from that height of instrument to get the readings for those locations.